Hello, this is the video submission for Team 16 Quad Tour, and our project is MIPS Assembler Disassembler. So, first of all, what is the motivation behind our project? So, our motivation was studying assembler and understanding program execution, and disassembler, which is an inverse of assembler and which converts machine code into human readable code. So our goal was to we set out to develop a system for assembling MIPS code and consequently disassemble the machine code to MIPS, which can support all three instruction format R, I, and J. So uh, uh, fortunately, we were able to successfully deliver this with a front-end user interface. Next, I come across this project idea and implement details for a project. These are all the architectural aspects, ISA specifications, and the supported instructions. Next, we have the file structure. So our code base consists of two Python files, which are the assembler and disassembler, and one more Python file, which is the server.py, which has the Flask backend, and all of our front end is within MIPS converter folder. Now, I'll walk you through the MIPS assembler implementation methodology. So basically, our assembler can be broadly divided into four sections. The first section consists of the hash tables arrays for storing instructions, formats, styles, opcodes, and functions. It also has a hash table of registers. Next, we have section on setting the passing rules for a MIPS program file, where we are identifying words, alphanums, registers, numbers, end of lines, etc. We also label identifiers, set RS, RTT, registers, immediate address values, and a format matching for three instruction formats. Then we read and pass contents of input MIPS file. Finally, once we have the tokenized instruction, we begin to assemble instruction into machine code. Let me walk you through the MIPS assembler Python file. So as you can see, uh, this is the instruction dictionary that we were talking about. So this is a hash table that shows various type of instructions with opcodes, format, style, and func. Then we have the valid instruction. Uh, Next, we have the declaration for setting the parsing rules. So this is the parsing rules. Uh, then we'll read the input MIPS file. Uh, yeah, and once we read it, finally we'll able to convert this into machine code. This is now we come across the disassembler code. So we have a table for opcode, funct, registers. Then we read the input machine code, and once we read it, we'll go able to generate MIPS code from the same. So yeah, so this is the screenshot for the same. Uh, so now we'll demonstrate our front end. So you can either type into this area or you can upload a file like I do now, and let me assemble this. So this is our machine code. Now let me disassemble the same. So as you can see, we'll able to successfully assemble and disassemble all the instructions that our program supports. Uh, And so, in conclusion, we'd like to say that after running the test, we can conclude that we're successful in building a simple MIPS assembler and disassembler that we use for assembling and disassembling simple MIPS instructions with support for over 37 instructions in 5 different styles. If we had more time, we could have added support for pseudo instructions, directive instructions, add support for user input, provide custom addresses to labels, to name a few. Um, Thank you. This was pretty much from our side.